Hello everyone, welcome to my channel. Today in this video, I'll be proving a theorem which states that a non-empty subset H of a group G comma star is said to be a subgroup of G if and only if for each A comma B belongs to H, A star B must also belong to H, which is a closure property. Secondly, for each A belongs to H implies there must exist A inverse belongs to H, which is existence of inverse. So since it is an if and only statement, first we have to consider H to be a subgroup of G. So let's proceed. The first part we'll be proving. First we'll consider H to be a subgroup. We have to consider H to be a subgroup of G. Now we see that since H is a subgroup of G, means H is also a group. H is also a group, which means first condition, which is for all A belongs to H, implies A star B belongs to H. For all A belongs to H, there exists A inverse belongs to H. Thus 1 and 2 are satisfied. Now we have to we have to prove it conversely. Now we have to see, let G comma star be a group and H be a non-empty subset of G. Such that we have two conditions here, A comma B. For all A comma B belongs to H, implies A star B must belongs to H. Secondly, we have to prove, or secondly we are given with, in case of solving it conversely, we are given with A belongs to H implies A dash belongs to H. Now, since by the definition of subgroup we know that a non-empty subset H of a group G is said to be a subgroup if H is a group with respect to binary operation of G. So we have to show H is a group. So first, in case of group, we have to follow closure property, which is let A comma B belongs to by condition 1. We are given condition here. We can see that first condition is A star B, A comma B belongs to H implies A star B belongs to H, which is none other than closure property. So first, our closure property is satisfied. Second, we have to prove associativity. So let us consider three elements belongs to H. Now we can see that since A comma B comma C belongs to H, then implies A comma B comma C also belongs to G. The reason is H is a subset of G. Now since A B C belongs to G, and the reason is since G is a group, therefore associativity is satisfied. Thirdly, we have to show existence of identity. Now let's put this as 1, 2 and 3 for more clarity. So from condition 2 we have that for all A belongs to H, there exists A dash belongs to H. Which means A into A inverse, it will be identity. Which means our third property is also satisfied. Now we have to check fourth property, existence of inverse. This also is already proven, since we have the second statement, given statement, which is for all A belongs to H implies A dash belongs to H. Therefore we can write from 2 for all A belongs to H implies A dash belongs to H, which is nothing but for all A belongs to H, there exists A dash belongs to H, which means A dash is inverse of A. So this property is also satisfied. Thank you.